Today, we're going to be going over more interval extrema. So let's say that we have this function, y equals x cubed plus 3x squared plus 2. So we can see right here that we go up, and then we hit this summit, and then we come down, and then we bottom out over here, and then we go back up again. So what if there was some way to figure out where these like these peaks are, or where we bottom out. So what if there was some way to find out where these special points were? Well, that's what we're gonna be learning about today. So we're gonna be using something called the second derivative test. So yesterday we were going over using the first derivative to find critical points. So today we're going to be using the second derivative in order to help us evaluate whether or not a point is a relative maximum on its interval. Like over this point over here, it's a relative maximum for its interval. Over here we have a relative minimum. And so the second derivative test will help us to find this out. So here are the instructions for how to find whether or not a point is a relative minimum or maximum without a graph. So first, you're going to want to do what we did yesterday, which is find the critical numbers. So that's a point where the derivative is either 0 or undefined. So next, you're going to want to take the second derivative and then plug in the critical numbers into the second derivative. So if your second derivative, so that would be f double prime of x, if that's greater than 0, then you get a relative minimum. And then if it's less than 0, then you get a relative maximum. And if it's equal to 0, then the test is inconclusive. So then step 3 would be to test also the interval endpoints. So when we have an interval, you're going to have to test the endpoints too. So you're going to want to I'll try to make this clear. You're going to want to test your interval endpoints and your critical points into the original function. If this isn't that clear yet, it'll be hopefully more clear in an example. So let's try it out. And I'm not going to ask you to, well, actually I will. So find the maximum and minimum of y equals x cubed plus 3x squared plus 2 on the interval -1, 2. So try to use the directions from the previous page. If you're struggling to understand it, then no worries, we can just go on right here. But for those of you who want to try this out, just pause the video and try this out on your own. All right, so first of all, we're going to want to find the critical points. And so we're going to take the derivative. And so we have 3x squared plus 6x is our derivative. And then we're going to want to find the points where the derivative is going to be equal to 0. And then this would be at the points, well, when x is equal to -2 and 0. And there's no undefined points for this derivative. And so we have when x is equal to -2 or 0, then we get a derivative of 0. And so those are our critical points. However, for this particular problem, we're only concerned with the 0. So we're only concerned with 0. We're not concerned with -2 because, remember up here, we're just trying to find out the maximum and minimum on the interval -1 to 2. So we see that -2 lies outside of our interval of -1, 2. So we're not going to worry about it right here. So we're just going to concern ourselves with the 0. Now we're going to want to take the second derivative, and then we're going to plug in the critical numbers. In this case, we just have one critical number. and that's going to be 0. So our second derivative will be 6x plus 6, and so when we plug in 0, we obtain a not y value. Let me repeat this. When we plug in 0 into our second derivative, we obtain a value of 6. And so since that's a positive number, we have a relative minimum when x is equal to 0. And so let's go back to our original function. So remember, our original function is y equals x cubed plus 3x squared plus 2. So we plug in our endpoints and our critical points into the original function. So let's see, our endpoints are -1 and 2, because remember, that's our interval. So plug in the endpoints of your interval. So we did that here and here. And then you also want to plug in your critical point. That's right here. And then you're going to want to see which points are the greatest and like which ones have the highest y values and which ones have the lowest y values. So let's see, when we plug in 0, we obtain our lowest y value of any of these 3 points. So that means that the point 0, 2 is a minimum. And then 22 is our greatest y value. And so that means the point 2, 22 is a maximum. And so that's how we can figure out whether or not a point is a minimum or a maximum on an interval. So that's it for today. Thank you for watching, and I hope to see you back soon.